A deck of 52 playing cards contain 12 picture cards. 2 cards from the deck are drawn at random and placed on a table. What is the probability correct to 4 decimal places that exactly 1 picture card is on the table? So you noted that, okay? There are 12 cards, 12 picture cards, and then 52 cards altogether. So what you need to do, okay, the best way to do this is draw a tree diagram. Okay, so let's say the first card you draw, you either get a picture card or not a picture card. Okay, so that's what it is. Now, to get a picture card is 12 out of 52. So therefore, okay, 12 picture cards. So therefore, the non-picture card would be 40. Okay, because 52 minus 12, so it's 40. So 40 out of 52. Then the second stage, because if you get a picture card already, and there are 12 of them, you got one already on your hand or on table, so you only have 11 more cards, picture card left. So you write 11. Okay, out of how many cards? That's right, 51. Because you already took one out, so 51 left. And then, so that's why you get 11 out of 51. Okay, this is called dependent probability. Okay, the second stage is the outcome of the second stage. It depends on the first stage. So this is picture card. Now, not picture card. Okay, so of course you just got 51 minus 11. Okay, so which is 40. Otherwise, because you got 40 non-picture cards, so which is 40 out of 51, of course, because you took one out. Then, if you got a non-picture card, so the second stage you draw, you either get a picture or not a picture card. To get a picture, because you get a non-picture card, so the picture card still 12 still left in a deck of cards, so that means 12 out of 51. Non-picture card, of course you took one out already. Okay, 40 of them, you took one out, so therefore you're only left with 39 out of 51. Okay, so that's what it is. Now, please keep that in mind for me, because these branch together add up must give me 1 whole. Okay, and similarly, these add up give me 1 whole. And then so is this. Okay, so just keep that in mind for me. So now, what is the probability? Okay, exactly 1 picture card. So 1 picture card means if you have 1 picture on this, then you must have the second one must be not a picture card, because exactly 1. So this branch, okay. So therefore, this branch, let's just write this here. The probability, okay, for this branch here is 12 out of 52 times 40 out of 51. Okay, add another one. This one here. If you draw a non-picture card, okay, the first time, and then you must have a picture card on the second time. So which is equal to, I write underneath, I run out of space, okay, so which is equal to 40, 40 out of 52 times by 12 out of 51. So if you put that in your calculator, you will get 80, okay, out of 221, which is fractions, but they want correct to 4 decimal places, which is equal to 0.36199 and so on. But they want 4 decimal places, which is up to here. 4 decimal places mean 4 number after decimal point up to here. You see? Before you write 0.319, okay, you look at this number first. This here, because it's from 5 onward, you add 1 to this, because it's 9. So your answer is 0.3620. Okay, 19 plus 1 is 20. That's all. Right, this question is actually 2015 HSC paper. Okay, and question 30. Now, on a tray, there are 12 hard center chocolates and 8 soft center chocolates. 2 chocolates are selected at random. A partially complete probability tree is shown. What is the probability of selecting one of each type of chocolate? So you know that there are 12 hard-centered chocolate, and then which is H, and then 8 soft-centered chocolate, which is S, right? So we need to complete the table. So the first range, if you select 12 hard-centered already chocolate, so you select 1, so 11 left, correct? For hard one. So which is 11. Okay, you took 1 out, of course, 11 left, and then out of 19, because you already took 1 out. Then soft center, because 8 of them, you took the hard one out, so you still have with 8 of them left, which is out of 19. Okay, now, these times, if you select a soft center, so to get a soft center, which is 8 out of 20. Okay, and the hard center, because the second stage, if you select the soft, the hard center is still 12 left. Okay, so 12 out of 19, so you took 1 chocolate out. So this one here, soft center, because you select the soft center already, so still have 7 left. So 7 out of 19. That's all. So you only need 1 type each. So which is, if you select a hard center, that means you need a soft one. Okay. Or if you select a soft one, then you need to have a hard chocolate. So therefore, the probability of this is P equal, okay, so P equal 12 out of 20 times 8 out of 19 plus, okay, 8 out of 20 times by 12 out of 19. So if you put that in your calculator, okay, you get 48 out of 95. Okay. Okay, this is 2014 question number 16, okay, on HSC paper. Now, in Mathsville, there are on average 8 rainy days in October. Which expression could be used to find a value for the probability that it will rain on 2 consecutive days in October in Mathsville? This is a multiple choice question, right? So the question asked is, okay, what is the probability of 2 consecutive days for raining, right? If you don't know how many days is in October, okay, this is how you count. So let's start from here. January, okay, January, okay, February, March, okay, April, May, June, July, and then you come back to August. So come back to this, so which is August, okay, September, October, November, and December. Okay. Now these are 31 days. Okay, 31 days, 31 days, 31 days, and 31 days. This is 30 days. Okay, except February. February is 28 days, except leap year, 29 days. Okay, so this is 30 days. 30 days. Now, because of October is here, so there are 31 days in October. Okay, so therefore, to work it out, okay, the probability of raining 2 days. So you got 8 because raining 8 days in October. Okay, so which is 8 out of 31, and then this is independent probability, so which is 8 out of 31 as well. Okay, if you're not sure, you can just draw the true diagram. Rain or not rain, so which is 8 out of 31. If you like, 8 out of 31. One rain again, right? So which is here 8 out of 31. That's all. So you just need to rain 2 days. So that's your answer. Okay, let's move on next questions. All right, so this is 2013, okay, paper. So if you look at this, okay, 2 unbiased dice, each with face number 1 to 6 are rolled. What is the probability of obtaining sum of 6? So now the way to go about this is not to draw a tree diagram because it's too much, because it's 1 to 6 and another 1 to 6 is like too difficult. So the best way to do this is I just draw a table. I just write 1, okay, 1 diagrams. I mean 1, 2, 3, 4, 5, 6. And I'm going to write 1, 2, 3, 4, 5, 6. So just draw a line on the number, okay, not between, on the number, just remember. So this is, I find this is much easier. So you draw on it, okay, just like this. Just quickly draw it, and then there you go. Now, they ask what's the probability of obtaining a sum of 6. So sum of 6, which is 1, if with first one 1, 1 with 5. Correct? 1 and 5 add up, give me 6. 2 must be 4. 3 with 3. There's a pattern. Okay, 4 and 2, 5 and 1. That's all. So 1, 2, 3, 4, 5. So 5 out of, because it's 6 by 6, so which is 36. 6 times 6, 36. So that is your answer. Okay? This question is actually some 2014 HSC paper. Jazz has 2 bags of apples. Bag A contains 4 red apples and 3 green apples. So 4 red, okay, and 3 green apples. Now, bag B contains 3 red apples and 1 green apple. So 3 and 1 green. Just chooses an apple from one of the bags. Which of the diagram could be used to determine the probability that Just chooses a red apple? So this is multiple choice. So you got 4 options. So option A is this, and then option A and B, and then you got C and D as well. So rather just look for the answer. Okay, you actually do it. Okay, so to work it out, then you just compare, and this is the easier way to do it. So should she have a chance? So I just choose a bag B, A, or bag B. Okay. Now the chance of choosing either A or B is a half. Okay, the probability of both is 50-50, so it's a half. Then if she choose bag A, so you have green, red, or green. Okay, to choose a red, you got 4 red out of 7 altogether, because 4 red and 3 green, so 7. To get green is 3 out of 7. That's all. Now, if she choose bag B, she also have a chance of probability of getting red and a chance of green as well. So get red is 3 out of 4. Green is 1 out of 4. Right? So the diagram for this, if you compare, because this diagram says what is the probability, okay, Just chooses a red apple. So the chance of choosing red. So which is the tree diagram for this is actually looking at this. So A, I think, look, we got a half and a half of course, and then to get red, 4, 7 and 3, 7 for green. Yep. And then the red one is 3/4 for bag B, and then quarter. So the answer is A. Okay, so if you look at B, it's wrong. The probabilities are wrong. And same with C, red, green, and you have to choose a bag before you choose anything else. So that's the answer is A. Okay. Last question. This is 2013 question number 30. Okay. So in a class there are 15 girls, 7 boys, 2 students are chosen at random to be class representatives. Copy and complete the tree diagram in your Answer booklet. Okay. So we'll just finish the tree diagram first and then we answer the question later. Okay. We'll just finish that first. Now, because true students are chosen at random. So the first one, if you choose a girl already, okay, so there are 15 girls and then 7 boys. So 15 girls, so you choose one already, okay, you got 14 girls left. And then out of 21 students. Okay, so this is called dependent probability. Okay, in another word, is not replacing. Okay, so you pick one, a girl, and then you pick another one. Okay, so which is 15 out of 22 for first stage, and second one will be 14 left, so 14 out of 21. Now, if a girl chosen already, if a girl's been selected, and then you still have 14 girls left, so you got 14 out of 21 students. Okay, 21 students altogether for the second stage. Now, you choose a boy already. For second one, if you choose a boy, you still have 14 girls left. So 15 girls left. So you got 15 out of 21 students. Now, second one, if you choose a boy, and then you still have 6 boys left. So 6 out of 21 students. So that's what it is. Okay, so this is tree diagrams. Now, I just move this up. Okay, the questions asked is, what is the probability that the true students chosen are of the same gender? So same gender means girls and girl, boys and boy. That's goes, okay, same gender. So the probability, okay, can be probability of girl or boy is equal to, so you look at this branch, the highlight one, which is 15 out of 22 times 14 out of 21 plus 7 out of 22 times what? That's right, 6 out of 21. Okay, sorry, I just moved this up a bit. So if you put that in your calculator, okay, you get 6 out of 11. That is your answer. Thank you so much for watching my videos.